brief introduction to alpaka, and now we have the recording enabled. So let's jump right in. Let's introduce alpaka. And there we go.
Hello everyone. Thank you for participating to the Alpaka and OpenMP workshop. This is the agenda for the Alpaka part of the workshop, and we are going to have a sequence of presentation and hands-on session pairs rather than having long explanations than long hands-ons. We will have small presentations and small hands-on sessions. The first, initially I'm going to introduce alpaka, then we are going to have a hands-on session which is about installing alpaka and running an alpaka example which exists already in the repository. Then I'm going to give another presentation about parallel programming concepts and portable parallelization by alpaka. Then we will have another hands-on session. In this hands-on session, in the second hands-on session, we will have an indexing example, and then we will continue with other presentations and hands-ons. Today we are planning to finish 5 hands-ons. If we can do, then 3 others will be done tomorrow. Alpaka is a library for C++. It is written in C++. Currently we use C++20 in development of alpaka. It is a header-only library, and no additional runtime dependency is needed. Compile time dependency is only boost, and including only alpaka.hpp to your programs would be enough. Alpaka supports a wide range of modern C++ compilers, C++, Clang, Apple, LLVM, MSVC, and it is portable across different operating systems, Linux, macOS, and Windows. If we just go over a list of HPC systems, we can see that hardware ecosystem is quite heterogeneous. The first one in the list, as you can see, Frontier in USA, is using AMD GPUs. Our Aura is using Intel GPUs. The third one is Eagle, which is using NVIDIA GPUs. And Fugaku is using CPUs, which are actually CPUs with ARM architecture. And Lumi in Finland is using AMD GPUs. And these different vendors propose different programming APIs. Even therefore, we can say that currently HPC platforms are not interoperable, or in other words, programs are not portable. Alpaka provides one API to support all different GPUs and CPU backends. Alpaka is an abstraction of underlying hardware, compiler, and operating systems. Alpaka does not have a default device, built-in functions, or language extensions, or default streams like in CUDA. It is easy to change the backend in code. Alpaka code builds down directly to vendor APIs, does not depend on any unified abstract APIs, therefore produces the same code that a vendor API would generate. That is important, especially for performance purposes. Supported GPU backends are HIP, CUDA, SQL, and Alpaca user can use vendor profilers and debuggers, even because Alpaca builds down to the same code. You can find us on GitHub. The GitHub includes full source code and many examples. And we have also an issue tracker. The documentation pages are at Read the Docs, and they include an installation guide, cheat sheet, and explanations about the Alpaca abstraction model. And we have an GitHub project group, which is called Alpaca Project Group, and it has some different applications. Contains all Alpaca-related projects. Kupla, for example, for easy porting from CUDA, and Vicuña is for high-level architectures, for example. Alpaca is a library for C++, and it is written currently, we are using C++ 20. And did I already? No. Okay. I have already summarized these informations actually. Alpaca uses shared memory parallelism. Shared memory parallelism model, in this model, all processors or cores within a computing system or node share the same physical memory space. And on the other hand, in general, we can say that for Lumi, for example, has many nodes, and there is another model which is called distributed memory parallelism. In this model, each processor or computing node has its own local memory, and no shared memory exists between the nodes. The processors must communicate via some interconnect or network to share the data. And for example, for node-level parallelism, HIP, CUDA, OpenMP, SQL, TBB can be used, and Alpaca is actually an abstraction for all of them. And for distributed memory parallelism, MPI is in general used. Okay, we are using node-level shared memory parallelism in Alpaca, and for example, in a single node in Lumi computer, we can see that there are 55,000, around 55,000 GPU cores, because each node in Lumi has 4 AMD GPUs, and each GPU has 2 graphics compute dies, and each die has 108 compute units. These compute units are units similar to SMs in CUDA NVIDIA GPUs, and each compute unit has 64 processing elements or cores. Then when a code uses a single node, and it can use 55,000 GPU cores in parallel. For node level parallelism, Alpaca can be used, and for distributed memory parallelism, MPI can be used, and they can be used together. This is Alpaca abstraction tree, and we have different backends in Alpaca to support different hardwares, and there are actually 10 backends or accelerators to support heterogeneous ecosystem. These backends are selected by the user in the code. Changing the accelerator or the backend in the code at a single line is enough to support different backends. Therefore, it is easy to change the backend in Alpaca code. The accelerator name actually has two important parts. First one is device type, CPU or GPU, as you can see, ACC GPU or ACC CPU serial. And the second part is specific to, which is specific to a specific API. There are 3 accelerator types for the GPU backends and 6 types for the CPU backend and 1 type for the FPGA backend. NVIDIA hardware is supported mainly through 3 compiler configurations which compile C++ and CUDA. AMD GPUs, for AMD GPUs, HipCC is used. HipCC plus Clang is used actually, and for SQL, for Intel GPUs, SQL backend is used, and it is using ICPX Intel compiler. Yeah, by SQL, of course, different GPUs and CPUs could also be supported. Yeah, this is the general overview of Alpaca.
So we have a question from the chat asking what is OpenMP. OpenMP in general is allowing you to write, for example, in C++ and Fortran at least, some pragma-based parallelism directives. So you can think of it as it's like a language extension. So if you have, for example, a for loop that you want to parallelize, you can just add a small pragma above it, and this will parallelize the for loop for you automatically. So this parallelism is passed on to the compiler, and the compiler does its magic. OpenMP is available as a backend for parallelization within Alpaca as well. So if you have an environment where OpenMP works, you can still use your Alpaca code and accelerate it that way.
Yeah, we will also show an OpenMP for loop in the next presentation to compare it with an Alpaca kernel. Yeah. Profiling and debugging Alpaca code is not difficult. And for profiling and debugging Alpaca code, vendor tools can be used because Alpaca builds down to the same machine code as the vendor solutions. For example, performance analyzers, profilers, sanitizers, debuggers already created by different companies can be used. For example, for HIP or for HIP, RockProf, OmniPerf, OmniTrace, AMD UProf, or RockGBD can be used. For Intel, if we have a SQL code which is running on Intel GPU, then we can use Intel vTune Profiler, Intel Advisor, Intel Inspector Debugger for Alpaca code executable and code. And of course for again Alpaca to profile and to analyze Alpaca code, we can also use Insight systems from and Insight tools from NVIDIA. I would like to talk about performance of Alpaca. A study for understanding the performance of Alpaca was carried out by Alpaca contributors and maintainers at CERN. 3 parallel programming tools are compared in this study: Alpaca, a similar abstraction tool called Cocos, and CUDA itself. The 2 graphs you can see on the left show the GPU and CPU utilization. In the case of mean GPU utilization, performances of three tools were similar, as you can see on the leftmost graph. But the CPU utilization of Alpaca was much better. The two graphs on the right show the peak memory usage. And the memory usage of Alpaca was much better for the GPU and slightly better for the CPU compared to Cocos. This performance analysis is done by CERN in 2021. But yeah, I would like to talk about also peak on GPU. You already know from the previous presentations. Peak on GPU project is one of the most important users of Alpaca actually. It is a particle in cell code and mainly does laser plasma acceleration. It is run on some of the fastest supercomputers actually for testing. The graphs show how the performance of peak on GPU scales as the number of nodes grow, according to the test performed on LUMI supercomputer. In the first graph, the problem size increased with the number of size, and in the second one, or in the one below, the problem size is kept fixed, and yeah. Hence, Alpaca makes peak on GPU to perform well on various different HPC platforms. And I would like to talk about partners using and contributing to Alpaca. And CERN is a very important user and contributor. DLR is using Alpaca, but their codes are not on public domain. We don't know at which softwares for what they are using. HZDR is an important user, of course, by creating peak on GPU, and HZDR is also directly contributing to develop and maintain Alpaca. And lastly, Helmholtz-Zentrum Berlin has started using Alpaca. On the other hand, since Alpaca is a part of Helmholtz roadmap from 2027 to 2034, a long-term support is already secured for Alpaca. As a summary, we can say that HPC platforms are not interoperable currently. I mean, the codes running on HPC platforms are not interoperable, or in other words, programs are not portable. Alpaca provides one API to support all different GPUs and CPU backends. And Alpaca is an abstraction, but it doesn't hide important features of parallel programming. That's an important feature of Alpaca, I think. Alpaca does not have default devices, built-in functions, language extensions. Therefore, it is, in that sense, not difficult for someone who is already has some experience on C, C++. It is easy to change the backend. That is important. Changing backend and compiling the code for another hardware is important. And lastly, I would like to again repeat that Alpaca code uses directly vendor APIs and builds down to the almost the same code with vendor code. Yeah, if you use Alpaca for your research, please cite one of the following publications. Thank you for attending to the first presentations.